What's up, guys? Welcome back to the channel. Today, as you can see on this video, we'll be doing this question paper that you see here. So this is a National Certificate Mathematics N4, and this question paper was written 30th July 2025, and it took 3 hours to be written. This video here will be focusing on question 2 of this question paper. And if you haven't watched question 1, I will leave the link on the description, and also the video will pop up on the top right of this video that you're watching here. Now, on your right, there is a QR code that you can see here. This is our QR code for the WhatsApp group. If you want to join our WhatsApp channel, you scan on this QR code, and also I'm going to leave the link on the description as well as the comment of this WhatsApp channel. All right, so before we start though, I will create a timestamp for each and every question for question 2, so that you can watch any question that you would like to start with, just in case you don't want to watch this question 2 in a sequence order. All right, people, before we waste any time, let's look at question 2. All right, here is our question 2, guys. Now, question 2, it's a combination of determinants and complex numbers. So we're going to start with question 2.1. As you can see, question 2 has 4 questions. So we're going to start with 2.1 here, and then we're going to copy this question, and then we paste it where there is space, and then we solve it. All right, we just copied 2.1. Now we are given the matrices here, which is a 3 by 3 matrix, and then we have the statement underneath there. Let's read the statement and let's see if we can able to solve this. The statement goes like this: prove using the method of determinant that expanding along the first row and the first column, the answer is 72. So the question here is to prove. So they want us to prove using the first row and the first column that our answer here of this matrix determinant is going to be 72. So I'm going to start with the first row, and then we do the first column. So I have to copy this matrix again. So the first column, we have 2, we have 3, we have 6. There we go. And then we have 4, we have 1 and 1. And the last one, we have 6, we have 5, we have 2. Right. So this time around, guys, what they did here is they chose for you which column to use, which row to use. So we start with the first row. There we go. So this first row here, they want us to use it as our minor to calculate the determinant. Now, before we do that though, we need to write the cofactor signs, which are alternating. Remember, the cofactor signs, guys, they are alternating. The first one, it's positive. Then from there, you alternate negative, positive, negative, positive. So we're going to have negative, we have positive. We have negative, we have positive, we have negative. And then we have positive, we have negative, we have positive. Right. I hope you know this cofactor signs. There we go. When we calculate the determinant, guys, on the 3 by 3 matrix, we need to use the minor and the cofactor sign. So the cofactor, the formula for cofactor, guys, let me write here. Cofactor, it's actually the following: it's minor multiplied by the sign. Then that's your cofactor, right? So let's do it. So when the minor, let's start here. Remember, when we use this as minus, so our minor here is gonna be 2, right? So we're gonna cancel the column where 2 is, and then we're gonna cancel the row where 2 is. There we go. So from here, guys, we can write when the minor, it's 2. There we go. Let's do it. So the determinant is as follow. When the minor is 2, right, we must calculate the determinant. So the simplest way of doing this, guys, is to cancel as I've shown you there. Now, you look at, first of all, you look at your minor, which is 2 there, and you look at the sign there. So we're going to write positive 2. So our minor here is 2. So what is it that we are left with here? We are left with 1, 5, 1, 2. There we go. and then we say plus. Do you guys see? Now this time around, when the minor is 4, remember we are moving on the first row, so we're gonna move this and cancel the row where 4 is and the column where 4 is. So let's do it. Let's look at the sign. We have negative. Remember this sign here, it correlates with our 4 there, so it's gonna be -4. So when we write it, we're gonna write it as -4, right? And then we write the matrix there, which is gonna be 3, right? 5, 6, and 2. There we go. I hope you guys can see. Now we move to another. When the minor is 6, minor is 6. There we go. Say plus there. Now let's look at the minor when it's 6. So we have to cancel the row and the column where 6 is. Here we go, guys. But let's look at the sign. The sign here that correlates with 6 is positive, and our 6 is also positive. So we're just gonna write 6 here, right? And then we'll be left with what? The matrix. We're gonna be left with 3, 1, 6, 1. Then there we go. So that is our matrix there, guys. I hope you can see that. Now I'm gonna create a little bit of space here so that we can able to solve this problem here. Right. So from here, guys, you calculate the determinant, guys. You calculate the determinant for each and every minor. So let's do it. So the determinant for minor 2, we know that this is gonna be 2, and then inside the bracket there, we multiply this entry and that entry, the first entry and the last entry, which is going to be 1 multiplied by 2, right? And then subtract, and then we multiply the second entry and the third entry, right? And then that is going to be 5 multiplied by 1. Then we close the close bracket, right? So we go to the minor when it's 4, so we multiply by negative there. We're going to have -4, and we have the open brackets there, and then inside there we're going to multiply 3 and 2 first, right? So it's going to be 3 multiplied by 2, and then minus. Always, guys, you minus the product of the second entry and the third entry, right? So 5 multiplied by 6, right? That's going to be 5 multiplied by 6. There we go. And then we close the bracket there. And then we do the last one where the minor is 6, guys. And then we do the similar thing. Remember, 6 is positive. We multiply by 3 and 1 there. So it's going to be 3 multiplied by 1, then minus. Then we have 6 multiplied by 1, or 1 multiplied by 6. It really doesn't matter which one you start with. 1 multiplied by 6. And then we close the bracket. And then we put all this in our calculator. If you put this on our calculator, the first one here, guys, is going to give us -6. There we go. The second one is going to give us plus 96. And then the third one is going to give us -18. When you add them together there, guys, this is going to give us 72. So we can say this is correct, guys. Remember, we need to prove that when we use the first row to calculate the determinant, we need to find 72. Now let me just zoom down to show you guys. Here is our answer there. Let me use red. Here is our answer there. There we go. So meaning this is correct, guys. The question was out of 8 marks, so this is the first 4 marks that you need to get. Now let's do when you use the first column as minus. All right, so let's do on the first column when you take the minus on the first column. So let's highlight the first column just like we did with the first row, guys, right? So the first column, we're gonna use the numbers in the first column as minor. So again, we're gonna cancel the first row where 2 is, and also we're gonna cancel the column where 2 is. Now let's calculate our determinant. We're gonna use the very similar method that we use when we calculate the determinant on the first row. So d is gonna be equaling 2. Now remember, this time the minor is 2 as well for the first one. Now again, we look at the sign here for 2. We look at the sign at the cofactor signs. We can see that 2 is positive, so this is going to be positive. But what is it that we left with there? The matrix that we're going to be left with is going to be 1 5 1 2. There we go. Then we are done. Then we move to another one. When the minor is 3, remember this time around we are moving with the column. Let's go. So we cancel a row and a column where 3 is. But let's look at the sign where 3 is. The sign, when you look at the cofactor signs that correlate with 3, it's negative, and then our 3 there, it's positive. So this is gonna be negative, guys. So we can say plus, and then inside there we're gonna put -3. There we go. Then we write our matrix there. So our matrix is gonna be 4, right? 6, and then we have 1 and 2. There we go. Now we do the last one when the minor is 6. There we go. Plus. Now we look at the signs. The sign here, it's positive, and 6 is also positive. Right. So let's cancel the row and the column where 6 is. So as for the column, it's already been cancelled. It's only a matter of a row. So our 6 is going to be positive. There we go. But what is it that we left with them? We left with 4, 6, 1, 5, and then that's it, guys, when the minor is 6. Right. So from there we start calculating. So let's create more space, guys, so that we can calculate the determinant. Remember, we use the method of calculating the determinant. So we have 2, right? And then we're gonna multiply 1 with 2 there, the first entry and the last entry. So 1 multiplied by 2, and then this is going to be minus by the product of 5 and 1, the second entry and the third entry. So it's going to be 5 multiplied by 1. Then we close there. Since we have -3 there, we're going to put -3 there. And then we're going to do similar there. We're going to multiply the first entry and the last entry, which is 2, multiplied by 4. So 4 multiplied by 2 minus, then we're going to have the second entry multiplied by the third entry, and then which is going to be 6 multiplied by 1. There we go, guys. There we go. So we do the last one where we have +6 there as our minor, and then we're going to do the very same thing. We say 4 multiplied by 5, right? So 4 multiplied by 5, and then minus the product of 6 multiplied by 1 then. So we say 6 multiplied by 1. There we go. And this is what we have. And then you take your calculator, you insert per each term there, guys. Right, so the first term, when I put it in a calculator, it's going to give me -6. And then the second term, when I put it in a calculator, it's also going to give me -6. And then the last term there is going to give me +84. There we go. And then all in all, this is going to give me 72. So our determinant here, it's also 72 when we use our column or the first column as minus. So guys, let me zoom down so that you can see. So this is how, guys, you do this one as well. The answer there is 72. There we go. The answer there is 72. So it proves that if you use the first column and the first row, you'll get 72. So this was just an instruction from the examiner to see if you can actually use any row or any column to calculate the determinant. All right, I hope you guys managed to understand this question. Really, it was not that difficult. As long as you know how to calculate the determinant on the third order, then it's way too simple, guys, right? But if it so happened that you didn't understand, you can go to the point where you did not understand, rewatch it. If that doesn't help you, you can ask on the comment section. But this part of the video, if it helped you and to understand, guys, do not forget to like, share, and comment on the comment section. If you haven't subscribed, subscribe to the channel. Again, my good people, I'm gonna leave a playlist of determinant on the top right of this video here. Go and watch it just in case you don't understand some of the things that I did here. There are videos that explains all the things that we did here. Go and watch that playlist. All right, people, we are done with 2.1. Let's do 2.2. Let's look at 2.2. As you can see, here is our 2.2 here, guys. I'm gonna copy it and then paste it where there is space, and then let's solve it. All right, guys, here is our 2.2. Now let's read the question and let's solve it. So this here is our complex number. They want us to express it in a polar form, and also we must represent it in an Gantt diagram. All right, guys. So first of all, let me just rewrite it here. Let me just rewrite it. We have z is equaling to negative 2 minus 3i. Right. Now here, guys, we need to calculate the argument and the modulus. So we're going to start by calculating the modulus. Guys, when you calculate the modulus, here's what you need to know. First, you must understand that negative 2 is a real number, so it represents x. And then negative 3i is an imaginary number, so it represents y. So we can use Pythagoras theorem to calculate our modulus. In this case, to be honest with you guys, is like our modulus is the radius. We just substitute the radius with the modulus. Modulus squared is the same as x squared plus y squared. Now you square root both sides here, and then you're gonna have modulus, right? And then you're gonna be having your x squared, but instead of writing x squared here, we're gonna write negative 2 squared. You guys see? Plus, and then we're gonna have y squared. Instead of writing y squared, we're gonna write negative 3 squared. You put this on your calculator, this is gonna give you root 13. There we go. Now this is your modulus, guys, right? Now it's time for us to calculate the argument. Now when you calculate the argument, guys, the best thing that you must use here, or the best trigonometric ratio, is tan theta, right? You can use any trigonometric ratio, but tan theta is best because you will be using the values that are given to you. If you use other trigonometric ratios like sine and cos, you have to use the one that you calculated here. And if you made a mistake there, you're gonna lose marks for this one. So we all know that tan is opposite over adjacent. Our opposite is y, and then our adjacent is x. So because this is happening on the third quadrant, we need to calculate the reference angle first. The reference angle, right? Instead of inserting negatives, you don't insert these negative values, guys, when you calculate for the reference angle. So you're gonna write tan theta, right? It's gonna be equaling to our y there is 3, and then our x is 2. Remember, when you calculate the reference angle, you do not insert the signs there, especially the negative signs. So then you're gonna say arctan, right? 3/2. So your reference angle, guys, is gonna give you 56,31 degrees. So this here is your reference angle. Remember, this is not the actual angle or the actual argument. So to get the actual argument, it's gonna be, let me say, theta. So like I said, this is happening on the third quadrant. This is the third quadrant because on the third quadrant, let me show you guys what we have here. All right, guys, on the third quadrant, as you can see, our x is minus and our y is also minus. As you can see here, we have -2 and -3. So how do we represent the third quadrant? By the way, guys, the third quadrant, this is how we represent it. It's 180 plus theta. So theta is our reference angle. Do not forget the one that we calculated here. So in order for us to get our actual argument, we must use that formula there. So it's gonna be 180 plus 56,31 degrees. And then our final answer, let me just create a little bit of space here. Our final answer here is gonna give us 236,31 degrees. So this here, guys, is our final answer. Let me highlight with the red pen. So remember, they said we must represent it in a polar form. So how are you gonna do it? So I'm gonna do it here on the side with the red pen. It's gonna be z is equaling to, you write your modulus, which is root 13, then you say polar 236,31, guys. You guys see, or You can write it like this: z, which is complex number, root 13, and then you write 623,631 degrees. So now we are done with how to represent this in a polar form. Now another thing that you must do is to draw the agar diagram. So before we draw the agar diagram, just in case you don't know how to do all these things that we just did, you can go to the description. I left a playlist of complex numbers, especially on how to convert from rectangular, which is this form, to polar. So go and watch those videos on the description. Now let me show you how to draw the agar diagram. Now remember, we are moving from 0, right? So you're gonna show there, and we stop here at the third quadrant, right? So this angle here, the whole of this angle, we say it's what, 236 comma 31. And then obviously you're gonna draw your line there. There we go. So this is gonna be your z, root 13, and then polar 236 comma 31. There we go. Guys, most of the time when you draw the agat, or when they ask to convert from rectangular to polar, just know that we usually want the positive argument. We know that this here was going to give us a negative argument, but we want the positive argument most of the time. So this is your agat diagram, guys. I hope you managed to do this one. Really, it was not that difficult. Again, if it's what happened that you don't know how to draw an agar diagram, I left videos on the description. Again, those videos will pop up on the top right of this video. Click on that top right icon, and also there is a link of those videos on the description. You can go and click on that link to watch the videos on agar diagram. Right, people, if this video helped you to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed to the channel. If you didn't understand, you can always rewatch from the point where you did not understand. Guys, you can support our channel by hitting the super thanks button, but if you can't do that, you can always like and subscribe to the channel. That will be highly appreciated. Guys, we are done with 2.2. Let's go and do 2.3. All right, guys, let's look at 2.3. Here's our 2.3 here, guys. So we're gonna copy it as well, paste it where there is space, and let's solve it. All right, my good people, here's 2.3. Let's read the statement and let's solve the problem. So the statement goes like this. They say simplify 3 plus 2i all over 4 minus 3i using complex numbers. So they want us to simplify these complex numbers that you see here. So I'm going to rewrite them again. As you can see, we have 3 plus 2i. All this is divided by 4 minus 3i. Right. So these complex numbers, guys, are dividing and also are in rectangular form. So when the complex numbers are dividing in a rectangular form, you need to multiply by the conjugate of the denominator. Now, when you multiply by the conjugate of the denominator, you must multiply both the numerator and the denominator with the conjugate of the denominator, this one here, right? So the conjugate is going to be 4 plus 3i divided by 4 plus 3i. There we go. So this on its own is also 1. Guys, the conjugate of the complex numbers in a rectangular form, you just change the sign of the imaginary number. As you can see, it was minus 3, but this time it's positive 3. And then you leave the real number as it is. Right, so let's do some FOIL. When you look at the numerator, we're going to have 3 multiplied by 4. That is going to give us 12, right? And then we have 3 multiplied by 3i. That is going to give us 9i. There we go. And then we multiply 2i with 4. It's going to give us plus 8i. There we go. And then we multiply 2i plus 3i. That is going to give us plus 6i squared. And then we divide there, guys, right? On the denominator, we're going to multiply 4 with 4. That is going to give us 16. We're going to multiply 4 with positive 3i, that is going to give us plus 12i. And then we multiply negative 3i with 4, that is going to give us minus 12i. And then we multiply negative 3i with positive 3i, minus 9i squared. There we go. And then from there we look for like terms, guys. Let's look at the numerator. We have 9i and 8i. You guys see, on the denominator we have positive 12i and we have negative 12i. Right, so let's start with those like terms. First of all, let's deal with the real numbers. So on the numerator we have 12 here, guys, and then we also have 9i plus 8i. This is gonna give us plus 17i plus. Right, now there's something that I need to inform you about. I squared, guys. I squared, guys, is equaling to -1. I've made a video introducing complex numbers. I'm gonna leave that video on the top right of this one that you're watching, that explain all this information there. Go and click on that icon that pops up there, and also in the description there is a link of that video. All right, so we're gonna write 6. Remember, I squared is gonna be -1. You guys see? And then we divide there. Now we're gonna write 16 underneath them. We have positive 12i minus 12i, that is gonna give us 0. Then you have minus 9, and then remember, I squared is equal to -1. Right, let's continue here on top. So on the numerator there, we're gonna have the following, guys. Let me just highlight. We have 12, right? Now this 6 becomes negative, so 12 minus 6, that's gonna give us positive 6. There we go. Right, and then plus 17i, and then we divide there. And then on the denominator we have 6, right, which is a real number. And then we have -9 multiplied by -1, that is going to give us positive 9. So 9 plus 16, this is going to give us 25. So your final answer here, guys, you can say 6 divided by 25 plus 17i divided by 25. Guys, that is your final answer. They just wanted you to simplify these complex numbers. They never specify, leave it in a polar form or rectangular form. So when it's like this, just leave it in a rectangular form. Guys, I hope you managed to understand this. Again, if you didn't understand, you can go to the point where you got lost, rewatch from that point, and make sure that you understand. If you don't understand, you can always ask a question on the comment section and I'll try to answer you. Again, guys, I'm gonna leave the playlist of videos on the icon on the top right of this video about division of complex numbers. Go and watch there, guys. On the description there will be a link of those videos. All right, my good people, if you want to support this channel, you can hit the super thanks button. But if you can't do that, you can always like and subscribe to the channel. Don't forget to share this to your friends. All right, we are done with this question 2.3. Let's go into the last question, which is 2.4 of question 2. Let's look at 2.4. As you can see, here is our 2.4, and 2.4 is the last question on question 2. So I'm gonna cut this question, paste it where there is space, and then we solve it. All right, here is our 2.4, guys. So let's look at 2.4. They want us to solve for x and y using complex numbers if given 4 plus j divided by 2 minus j is equaling to y minus j divided by x. Right, so guys, whenever you see j, this is supposed to be j, guys. Whenever you see j, it's another notation for imaginary number. Right, so they want us to solve for x and y given these complex numbers here. So I'm gonna copy this question and then let's solve it. So we have 4 plus j divided by 2 minus j. All this is equaling to y minus j. All this is divided by x. Right, so in order for you to solve for x and y, you need to simplify this expression here. So we have to cross multiply, guys. So if you cross multiply on the left hand side, we're gonna multiply with x, and then we have x multiplied by 4 plus j, and then on the right hand side we're gonna multiply 2 minus j multiplied by y minus j. There we go. Now on the left hand side we're gonna remove the bracket by multiplying x there, so we're gonna have 4x plus xj. There we go. And then on the right hand side, unfortunately, we have to do the FOIL. So 2 multiplied by y, we're going to have 2y. There we go. 2 multiplied by negative j, we're going to have negative 2j. Right. Negative j multiplied by y, we're going to have negative yj. There we go. And then negative j multiplied by j, we're going to have positive j squared. There we go. Now, we have to simplify further. Guys, you cannot do grouping when we have some simplification to do. As you can see, we have j squared, guys. J squared, similar to I squared, is the same as -1. Again, guys, if you haven't watched the videos, I left a video that explain all this on the description. Go and click on those description. Right, so let's go back. So we look for the like terms. If we do have like terms, they will cancel each other or add each other. If there's simplification, we simplify. But on the left hand side, we have 4x plus xj. There we go. And then on the right hand side, we have 2y minus 2j minus yj. But instead of writing this j squared, we're going to write it as -1. Remember this information here. Then from there, we start grouping, guys. So let's group. So when you group, guys, we're going to consider this expression here. As you can see, this expression, there's no simplification required. So we're going to group based on real numbers and imaginary number. So let's start with real numbers, right? You just write real. Underneath there, you write only the real numbers, right? On the left hand side and on the right hand side, right? So on the left hand side, the real number that we have is going to be 4x. Do you guys see? We don't have any other real number, so we equate them. Then on the right hand side, we have 2y, and we also have -1. Guys, the real numbers are the numbers in this expression here that don't contain j. If they don't have j, just know they are real numbers. So this is your equation for the real numbers. But let's make x subject of the formula. Let's divide by 4 here throughout. There we go. If we divide by 4, this becomes 4 is equaling to 1 over 2y minus 1 over 4. So this is equation 1. Now, let's group imaginary numbers. You can write im, it's fine. Now, you look again on the left hand side. A number that contains j, it's an imaginary number. In this case, it's only x. Guys, don't include j here, because this im here represents that any number that is underneath this is an imaginary number, right? So on the left hand side, we have x. Now there's no any other imaginary number. Now we go to the right hand side. The right hand side, we have -2 and then -y. That's it. That is our equation 2. In order for us to get x and y, we need to use simultaneous equation. You can also use elimination, but I find simultaneous equation to be the best between the two. So I'm going to create a little bit of space here so that we don't get confused. So you can substitute 1 into 2. There we go. So here's our 1. Our 1 is equaling to x, and 2 is also equaling to x. So we can equate these two equations. Yeah. So we can say 1 over 2y, which is equation 1, minus 1 over 4 is equaling to -2 minus y. There we go. So all you have to do here, we play the transpose game, guys. So let me create again space here. This time around, I'm just gonna do it on top there. So we can transpose this y to the left hand side, and we transpose this negative 1 over 4 to the right hand side. So let's do that. If we transpose the y, let's start with half y. If you transpose negative y on the right hand side, it's gonna become positive y, you guys see, and equaling 2. And then we have negative 2 there. And then if we transpose this negative 1 over 4 on the left hand side to the right hand side, it's going to become 1 over 4. There we go. And then we use our calculators. Half y plus y, this is going to give us 3 over 2y. There we go. Negative 2 plus 1 over 4, this is going to give us negative 7 over 4. There we go. And then from there, guys, we just divide by 1.5. We divide by 3 over 2 throughout. 3 over 2. This 3 over 2, they're going to give you 1. You're left with y here. And this one is going to give you negative 7 over 6. So our y here, it's negative 7 over 6. So in order for us to find x, we can substitute y into one of the equations. So I rather choose the second equation into 2. This one here, it's easier, guys, to follow. Rather substitute my y here, right? So let's do it. Let me change the color very quickly. So we know that x is equaling to negative 2 minus, wherever there is y, we're gonna put negative 7 over 6. And then our final answer, let me just create a little bit of space here, guys. Our final answer, x, is gonna be negative 5 over 6. There we go, guys. Here are our answers. We have y there and we have x there. So this is how you're supposed to calculate your x and y, guys. Again, here on this part of the chapter, I've done a video explaining how to solve for x and y. I'm gonna leave the link of those videos in the description, and also that playlist is gonna pop up on the top right of this video that you see here, guys. Go and watch those videos in that playlist to understand better on how to solve for x and y simultaneously in a complex numbers. I assume you guys managed to get this. If you did not get this one, please go back to the point where you got lost, rewatch it, and if that doesn't help, you can leave a comment in the comment section. Again, guys, if this helped you to understand, don't forget to like, share, comment, and subscribe to the channel if you haven't subscribed. You can always support our channel by hitting the super thanks button. If you can't do that, guys, a like, a subscribe, and a comment will be highly appreciated. Alright, guys, we are done with 2.4, and also we are done with question 2 as a whole. So we will be doing question 3 soon. So make sure that when you subscribe, you hit the bell notification, so whenever I upload a new video, you get notified. Thank you very much, guys, for watching. Till next time, cheers.